an epoch called the Pleistocene, which is a fancy sounding, hard to spell, and hard to pronounce word. I miss the old word for this. So, scene, that part at the end, is just another word for age or epoch. And Pleistocene is just another word for stones. So really, we're in the Stone Age. Stone Age is pretty long. Started, we're going to say about 2.6 million years ago, up until about 12,000 years ago. We call it the Stone Age or the Pleistocene because of some of the stone tools that we have found during that period, and those are the things that have preserved. These are from South Africa around 500,000 years ago, and they were probably attached to wood to make a spear. So the wood part of this and the other tools and other things that were used during this period have disappeared. Later on, we'll talk about other tools that then have been preserved starting at about 12,000 years ago. But for this era, we are in the Pleistocene or the Stone Age. This boy, the Nariokotome Boy. And yeah, this is 1.6 million years ago. Estimated height would have been an adult height is around 6 feet tall. That's wild. Up until now, we've been talking about Australopithecines and other bipedal primates, and maybe even some of the early Homo species being 3 or 4 feet tall. So now we're getting some skeletons in this 6 foot range. It's a Homo erectus. We're there. We're at the Homo erectus stage. These creatures that we named Homo erectus come in about 2 million years ago. This one's from 1.6, but they come in from around 2 million years ago. We get taller, we get longer bones, we get this is a pretty complete skeleton. These were found in various parts of the world, and they named them Homo erectus because they believed at the time that this was the first upright Homo species. We now know that was a long time ago that you had upright bipedal creatures, but the name has stuck. But yeah, this is a pretty amazing thing. So we're at Homo erectus. We talked about being 6 feet tall, and not all of them were going to be 6 feet tall, but some of them. And we have more footprints around. So in the last class, we talked about the litholy footprints of the Australopithecines at about 3.5 million years ago. That you can see that they're bipedal, but they're 3, 4 feet tall. The brain size is still pretty much the same as a chimpanzee. They are habitually bipedal, and we had good evidence of that. But for the Homo erectus, these are footprints from Ileret, Kenya, at about, again, 1.5 million years ago. And you see that they are not only fully bipedal, you can put your own foot in the footprints, and it pretty much matches up. So they have the same gait, the same aligned big toe, double arches, similar stride length. So this is Homo erectus being tall and walking pretty much like we would. Yeah, there were definitely a range of Homo erectus skeletons, and they weren't all tall, but the point is they weren't all 3 feet tall or 4 feet tall like they were back when Australopithecus around. There's going to be variation. We talked about the variation in human height among different populations and throughout time before. So, but yes, we see Homo erectus. There are some pretty tall individuals there. Remember, a lot of these were more robust. They were larger and stronger than we are today because they had to deal with different things. But what about their brains? Now, it is important to remember that brain size within a species maybe doesn't say as much as we want it to. So the idea that some people have big heads and bigger brains and that means they're smarter. No, what matters more is the organization and the complexity of the brain. However, between species, we see this increase in brain size. Between species, you can see that these creatures are using their frontal lobes more. We know obviously they have to communicate with each other. They probably didn't have fully developed language, but they seem to be getting ready for language. Language ready. This brain reorganization that takes place and the head reorganization is important to understand. But again, we don't want to equate, especially within a species, brain size to intelligence because it doesn't work that way. It has to do with brain organization and brain complexity. But Homo erectus is developing quite a large brain and quite a complex brain over time here. Brains don't fossilize. You're trying to base this on what they call an endocast. You're trying to take a skull and pour stuff into it and then try and figure out what the brain might have looked like or the shape in there. So let's go to the hand axes. So on the one hand, these are definitely more shaped than what we saw, those pretty basic stone tools. They have been deliberately cut and in some cases recut. The word hand axe, which they've decided these things should be called, is deceptive. They're sharp all the way around. So to hold them in your hand and try to do something with it, you'd probably end up getting your hand cut up. They don't seem to have been fixed to any, there's other things that we know that were fixed to spears. There's some of these that might have been, but there's no evidence that there were, and they're too big. Some people speculated that people used to throw these things like a discus. But then if you try that, it doesn't work very well. It's not great at that either. So there's been a huge debate about what these things were used for. There's a long tradition of them. They lasted for about 1.5 million years where you see people work on these things. They persist and they have a pretty big geographical range as well. So people have really debated. We still don't really know what these things were used for. They're sharp all around. They don't seem to have been affixed to things. They're not very good for throwing. Some people have speculated that they're simply the byproduct of other things that were made. So they're like the stuff that got left over after you're done making another tool, which then disappeared. What seems to be the best case scenario is that they were used in butchering and in scraping things, and you could use them for that. But there's still some debate about what exactly they were doing with these things. But our best hypotheses now are the butchering of animals, getting marrow out of bones and getting to nutrition points that other creatures maybe couldn't get that were predators and other scavengers, perhaps made us more efficient that way. But yeah, these things are very cool, but still a mystery. Homo erectus comes out around 2 million years ago and is the first bipedal primate to leave Africa and end up in parts of Europe and over here in Asia and all the way down into this island. So a pretty big geographical spread and range. And they seem to be one species, but there's a lot of regional variation. There's a lot of differences between them. There's more genetic variability and there's more physical variability than we might be used to among ourselves. We think we look different from each other, but these Homo erectus populations really ended up adapting in various ways to these climates and looking pretty different. Most people think they're still one species with regional variation, but they end up looking quite different from each other with varied brain and body size across these regions and a lot of adaptations to different environments here. With the spread of Homo erectus into 3 different continents, Africa, Europe, and Asia, was living there. We then have this period which we call the Middle Stone Age and the Middle Pleistocene Homo species. These creatures were once called archaic Homo sapiens. That is to say, we called them old school Homo sapiens. But that's obnoxious in a way. You're saying these are the creatures who are waiting to turn into Homo sapiens. They really weren't. They were doing their own things and they had a decently successful run. We know that they're somewhere between Homo erectus and Homo sapiens. So we're now just going to call them Middle Pleistocene Homo. They had different features, and some paleoanthropologists and archaeologists call this period the muddle in the middle. And the reason they call it that is because there's a lot of good evidence that we have for what was happening with Homo erectus at 2.2 million years ago or 1.5 million years ago. And then at about 300,000 years ago, as we'll talk about, and 200,000 years ago, you see Homo sapiens emerge, and we got good evidence on that. But in this period, things get confusing. There's different regional stuff going on. They look a lot different from each other. They seem to be developing in different ways. There is some cool stuff that they were doing or developments that they had. There's these tools that they use. This is an example of scrapings on an antler bone. And they developed something that was called a pressure flaking technique. So you have much more specialized tools and you can do much more fine-grained work. So unlike some of those hand axes, which are large and cool and sharp, in this case, there is evidence that there were things that were put onto spears and other things that you could throw, little knives and scrapers. So you can make much more fine-grained and sophisticated tools. And what that meant is that the Middle Pleistocene Homo were able to hunt and to gather in various regions of the world. We often put a big emphasis on hunting because those are the kinds of things like bones and spears and hunting instruments that get preserved. But gathering, whether it be tubers or berries or some form of wild plants, is often in these cases worth as many calories as the hunting part and is perhaps on a day-to-day basis as or more important than the hunting. So this is how there was no agriculture at this time. People had spread out into these areas of the world, but they were using a hunting and gathering tradition. We also have evidence that they were able to use fire and control fire. Now, there's been a lot of debates about when fire gets used and controlled. Some people have wanted to put that back about 2 million years ago with Homo erectus and say that they controlled fire. It's hard to distinguish sometimes between simply fires that might have been lit accidentally or by lightning and those that were controlled. Most people put the control of fire in this middle Pleistocene or middle Homo range. And that means you get light from fires, you get heat, and cooking. In order to support large-brained infants who are dependent on your group, you need to have oftentimes more calories, and the cooking of plant and animal foods seems to be able to deliver that in a way. And then your head form can change. Now, then you can develop different teeth and your jaws don't have to be so massive. It can change and then you can support a larger brain without having to have a huge jaw and teeth. I would say large brains can also be a disadvantage too. Let's put it that way. Wow. How? Because you have to feed hungry little kids and their brains are growing and they can't contribute to the survival of the group. What the brains do, though, I will say, is they give you more flexibility in different environments. These creatures seem to have been able to learn from each other and spread out into different places and then change their habits to go and change and to adapt to different environments. I'll say two things. First of all, remember the first thing that happens that differentiates our lineages from the other primates as we become habitually bipedal. Brain size doesn't really change for 4 million years after that. Then you have some of the tool use coming in. Again, not too much difference in brain size. We see a pretty big difference in Homo erectus, but then it stays stable. I would not put it all down to brain size, but it does become important at this, at least between different species. And the fire part and the cooking part and being able to deliver calories is a key adaptation, because if you don't have that, if you can't deliver calories to your infants, then brain size really is a disadvantage, because you need all the people in your group working. You can't be carrying helpless kids around all the time. You gotta get them to work, get them to support themselves. If we look at what happened in the middle Pleistocene Homo, there's a lot of different regional variation in these different places, and these groups show a pretty large variation in terms of brain size. The first large-brained Homo species that we classify as part of the Homo category, that is, their bodies and their brains, appear in Africa at about 800,000 years ago. So out of this muddle, you might say, starts to emerge creatures that look more like Homo erectus is tall and bipedal, but also has these huge, large brow lines and has a lot of regional variation. You start to have populations that emerge in Africa first that we classify as Homo sapiens. So we have at about 200 or 300,000 years ago, from the Middle Pleistocene Homo populations, creatures that we would then classify as Homo sapiens. Now, in anthropology, there are a number of different models for how we got from Middle Pleistocene Homo or from Homo erectus to Homo sapiens. For a while, people believed in what was called a multi-regional model. The idea was that Homo sapiens emerge in all of these areas, Africa, Europe, and Asia, and they're connected by gene flow, but they emerge separately. We now have much better genetic evidence, which indicates that the first, what we call modern humans or Homo sapiens, originate in Africa. Some of the large-brained Homo species, and then they move again from there, out from Africa into Europe and Asia, and replace what we would call the old style Homo species that were there. For a while, we believed that there was no interbreeding between the Homo sapiens of Africa that emerged, but now we know that there was some. So there was some interbreeding, especially in the Middle East, with species that we'll talk about, like the Neanderthals. And also later on, we've discovered with a new species we call the Denisovans here over in the Asian part of the world. So there was some interbreeding, but the main model that we have is of Homo sapiens emerging from Africa at about 200 to 300,000 years ago from these populations of the Middle Pleistocene period, and then spreading into other parts of the world after that. So it looks like, genetically speaking and physically speaking, all of us humans alive today, the one interbreeding species that we call Homo sapiens, descend from a population of about 30,000 Homo sapiens in sub-Saharan Africa at around 200 to 250,000 years ago. And that's one of the reasons why we're so genetically similar. There would have been a lot more variation among these species back in the day than there is between us today. So we get a lot of genetic similarity, in part because it was such a small, bottlenecked population. 30,000 individuals is all the Homo sapiens that were around and who were all descended from. And so from Africa, and out of that African origin, then these Homo sapiens populate the globe gradually or in stages. Now, the question has been asked, well, wait a second. If we're so genetically the same, then how come we look and act so differently from each other? Many of the physical changes that we see are not because of our genotype or not because of genetic change, but are recent evolutionary adaptations that happened in the last 50,000 years or so to specific climate variations. And to add on to that, we also have cumulative culture developing in different parts of the world. So they give you this map, and it's worth reflecting upon. We have the emergence of Homo sapiens at about 200,000 years ago here. And for the first part of time, we just have lots of interaction within Africa. So lots of stuff going on in Africa, and Africa is a huge place. Lots of things that went on there. And then we have people moving into this area of what we would call the Middle East, 75, 50,000 years ago. This is where we see some evidence of interaction with other related, closely related species like the Neanderthals and probably some interbreeding. We see an incredible migration in which people make it across the Wallace Geography Barrier and down into Australia at about 65,000 years ago. We have found art. We have found cave paintings in this area of Indonesia, as well as the more famous cave paintings of Europe at about 45,000 years ago. But we see creatures, Homo sapiens, painting and making art and musical instruments across the world. We have evidence of that at 45,000 years ago. So this seems to have been something that emerged in Africa as a package of stuff and then was used to populate different parts of the world. We have people coming around here at about 45,000 years ago, in this area of Siberia at about 25,000 years ago, getting into the Americas somewhere around 16, 15, 14,000 years ago. In all of these different places, you have geographic adaptations, recent evolutionary changes because we're such a plastic, or we have a lot of genetic adaptive plasticity. You see physical changes, but you also see people doing different things with how they are able to learn and learn from each other in very different places. Because of cumulative culture, because we learn how to do things from our peers and from our parents, in these different areas of the world, they would develop traditions, hunting patterns, artistic patterns, dance patterns, singing patterns, language differences, which make us seem very different today. When people re-encountered each other, say 500 years ago, when you have some of the people in these different continents coming back together, there was a lot of speculation on why are people so different from each other. And it took a long time to figure out that we're very the same. Physically, we do look different from each other, and culturally, or what we can learn to do, makes us quite different from each other. But we're all one lovely interbreeding Homo sapiens species. This is an incredible migration at about 2,000 to 3,000 years ago, getting out to Hawaii and Easter Island and down into New Zealand, these islands just sailing off, not knowing if you'd ever come back. It's been a good spread, us large-brained Homo creatures. Not sure the large brains is such a huge advantage if you're going to use them to then heat up the world and or nuke everybody. You have a big brain, you come up with a nuclear weapon, and then you use it, and then you're all dead. That's not an advantage, but we'll see. how good we do with our big brains.